Hello everybody and welcome back. I'm quite loud so you can kind of semi-hear me. Welcome, welcome, welcome. Hope you've all been fed. Told you the food is amazing here, isn't it? Yes, it is. We will have a session now and then what will happen, that will flow into a panel discussion after that as well. And then we've got a keynote speech after the panel discussion too. Right, the next session is really interesting as it covers how FANUC plans to incorporate digitisation and IIoT, and of course the panel discussion will happen straight after, so that's really a chance and a moment for us to open the floor and for you to get involved as well. So please welcome on stage Konrad Gross. Thank you.
Yes, now. Yeah. Welcome, good afternoon. Hello again. I have a challenging role to wake you up after this wonderful lunch, but I hope I will manage. And today I'm going to talk about industrial IoT. FANUC is not very well known from industrial IoT. We are very well known from our robots, our automation systems, our machines, but IoT is a new area for us. And I would like to share with you our experience so far and our vision for the future. So, yeah, I have already 23 years of experience in different areas related to PLC, business, SCADA. 20 years ago, the IoT was not called IoT, it was SCADA software at the time. And everything, the purpose was to visualize the problems of the customers and help them to take the right decision. So I joined FANUC in 2007, and I started to, my role to manage the business of robotics and machines in territory of Poland for FANUC. And in 2014, I moved to Luxembourg, where I had different roles. And currently, I'm responsible for IoT business in Europe. So my role is to support different FANUC subsidiaries, including FANUC UK, to establish the successful IoT business. So my aim and my mission is to help the customers to increase the competitiveness based on more efficient production. And it's in good relation with the topics of this conference that we need to increase the competitiveness of British industry. So, yeah, we were experiencing different ways of introduction of IoT to customers. And in the past, we showed a lot of complicated and complex diagrams of architecture, network, cloud, digital twin, all these buzzwords, which are very easy to understand by us as engineers, but not easy to understand by customers, especially decision makers who have to spend their money and they are looking for savings, they are looking for improvement of their financial situation and their competitiveness. So we decided to talk about benefits. So how IoT can help customers to improve their productivity, how to produce more parts and products within the same amount of machines, the same amount of robots, the same amount of factory footprint, how to maintain the quality on the desired level, how to make sure that the quality will always be within expected tolerance, that the quality will be monitored continuously, and before it goes out of tolerance, the system will do something, inform the person or automatically correct. How to improve the uptime. So, yeah, we have in every production, we have some equipment, some machines, and everybody will dream that these machines will never break. But there are some methods, which I will talk later, how to prevent the downtime and how to improve the uptime of production so we can, again, improve productivity and quality. Yeah, everything here is related. So the downtime could, or the machine not correct maintenance, they could create the quality issues and productivity issues. And the last but not the least, the production cost could be reduced. So energy consumption could be reduced, the material cost, tool cost could be reduced, and overall efficiency of production could be improved. So FANUC produced many IoT software over the years, and we discovered also that to really satisfy the customer requirements, we need to work with different partners. And we established the open platform, which is called Field System, where we collaborate with different manufacturers of equipment, but also software companies. And we invite every software companies to work with us to bring more value to our common customers. Because as was mentioned on the first presentation today, we also dream that everybody is using only FANUC equipment, but it's an unrealistic dream, and always customers will have different vendors, different machines, different even generations, and we create a platform which is able to gather the data from all this equipment being analyzed and give the customer opportunity to take decision and improve, again, productivity, quality, and uptime of production. So these are the examples of the software packages which we presented last month and machine tool trade show, EMO. But these are just examples, just to inspire customers, give them possibility to imagine what you can do with this IoT software. But this is not the end. This is just example which yeah, there is a lot of software solutions which are between this lines and what our partners could do. So everything has to start from the requirements of the customer. We would like to understand the requirements. And when we talk about requirements, we try to inspire customers and say, oh, for example, for productivity improvement, we could help you to analyze the CNC data to shorten cycle time. Are you interested to reduce the cycle time and to produce more parts per minute, per shift, per day, per year? Or we say, we can help you to understand the real performance of your production and compare it to the planned production. So customers, many customers, they have this information already in the type of andon boards or other visualization equipment, but very often this information is not accurate. It's not gathered from the machines directly, but it's put manually by somebody. And the customers would like to have a more accurate information, to have a real situation feedback. And also the systems, IoT system could help the customers to compare productivity between different machine groups, between different machines, between different operators, and this comparison could help customers to drive conclusion how to select next machine for next investment, or maybe optimize specific equipment on the machine. Like we have customers who have the same machines, but they use different tooling, different fixtures, and they, by comparison of production on this different equipment, they can drive conclusion what is optimum configuration for this particular product. Yeah, regarding quality improvement, there are much more interesting examples. Your customers can have a system which analyze the quality measurement results, and as you know, the quality is coming more and more to production sites. So in the past, the quality measurement was done in the separate room, temperature control room, and the products before being measured spent some time in the production, and there was if the quality issue occurred, in the meantime, the bad quality parts were produced in a substantial scale, so customer reaction time was delayed by hours or sometimes even more. So now we bring the measurement equipment back to the production, and this measurement equipment can compare the results of a previous measurement with the current one and analyze trend. If the trend goes in the direction that probably the quality inspection will be not accepted, then the system could inform the operator, or the machine can stop and call the operator, or even the machine can get the correct tool offset corrections and compensate, and bringing back the quality to desired level. So we already have this kind of solutions in place, and working with companies like Mitutoyo or Renisho to execute this objective of the customer. Yeah. Then another one is the traceability. So when you collect just the quality data, it gives you some information. If you collect the real production data, and you are able to correlate production data process parameters with the quality, you can get much much useful conclusions for improvement of quality. And also the area of AI-powered computer vision gives opportunity to automate the quality inspection, to find the technical problems which are not visible by human eye, or they cannot be spotted by the human operator and currently used vision systems. So as you know, AI can be trained to look for the quality issues which are not really defined, which are not trained. The computer vision which is used until now is typically looking for the failures which are defined, and computer vision is looking for something what is trained. But the current AI-powered computer vision can look for the non-defined failures and give the quality being more automated or even less expensive. So customers have typically problems with the quality inspection takes too much time, and they would like to reduce the time, but also that the quality inspection is not accurate enough, and they get the information about quality failures when the customer complains. And also there is quality improvement possible with IoT system when you record program changes, or when you have a system which can recover the program to original setting. And this kind of software also existing, and if you are interested, I would be happy to explain in details after my presentation. So today I have just 15 minutes to just inspire you, but we are very happy to talk to you, and our colleagues from IoT related topics like Luke sitting there, or Steve, they are happy to talk to you during the break. And very popular item in relation to IoT is downtime prevention and machine monitoring. And my thoughts about this is that yes, it's very important to analyze data to prevent downtime. I will talk about this later. However, for reliable machines like FANUC machines, this is not a top priority for customers. We have sometimes discussions with the customers that do you want to prevent the data of FANUC RoboDrill and prevent the downtime of FANUC RoboDrill? And the customers say no, because the FANUC RoboDrill is very reliable, and when it fails, FANUC service arrives next day, I have no problem. I would like to analyze some other areas of my production for improvement of uptime. So this is important subject for us, and we continuously improve our software. I will show you later, but the most important for customers is to see overall production uptime. So every equipment, every sensor, every conveyor which is used by customers should be reliable and never break. Yeah, and also big area which is very interesting for customers is reduction of the cost. So energy consumption is getting more and more interesting for customers, especially when the energy cost is growing so quickly. There are possibilities to reduce the energy consumption. Tool cost reduction is incredibly interesting, because every customer knows how much they spend for the tools. And if we can reduce the tool cost by 10%, 5%, it's very interesting budget for the IoT system that customer can utilize. And also the reduction of scrap production and comparison of machining results help customers to select specific tool vendors and machine manufacturers and so on. I will go to the most interesting examples. For many years, we have a software called MT-Link-I, and recently we interviewed the customers who are using this software to analyze how they benefit from the software. So this example is the user's, specific user actually in Germany is analyzing the specific parameters in the machine tool. For example, the pressure of the clamping when the workpiece is clamped before machining. If the pressure is going out of normal situation, this is a good indicator that the workpiece is not correctly placed in the. So this will indicate that when machining will start, there will be quality issues. So in this kind of event, during night shift, the user can get a notification by email and fix the problem with the fixture. So this user actually told us that they don't want to monitor the situation on the production every minute, every hour. They would like to be just notified when something is going wrong. Another example is the usage by this is a small medium company where the CEO of the company, whenever he touches his PC in the morning, when he opens, he doesn't use any Outlook or other software. He's using MT-Link-I to see what happened on the night shift. And on the night shift, he can see that the machines, some machines were working, but some machines were stopped. And then what he's doing, he's going down to his production people and ask them what happened between 5 and 6 o'clock in the morning. Can you explain me? And they say, for example, there was not enough material or there was some problem with the machine. And then they can take the action for improvement. So this we talked today already, that just the software installed on the user PC doesn't help the business, but the action taken by the customer based on the software information is the real benefit. So there's also very trivial example of visualization. So the customers, they put this kind of visualization screen on a big screen in the production hall, so everybody can see which machines require intervention. So this is very simple example, but very often customers have less operators than machines. So these operators are busy in the production hall, but if they have overlooked screen somewhere in the place when everybody can see, this very simple solution gives a lot of benefit. And I was surprised that customers indicated. And also I would like to share with you at the end of my presentation the ZDT experience. ZDT is zero downtime software made by FANUC to monitor FANUC robots. And basically we analyze the parameters of the robot to prevent the downtime before it will occur. So customer can make a preventive maintenance work when the production is planned to be stopped. So as you can see on the screen, we can the system is analyzing every day, analyzing the movement of the robot and compares the parameters of the servo to the normal situation. And then basically throughout the time, the movements get more difficult for the robot, and you can indicate when you need to do something, for example, to add the grease or change the grease in the robot joints to prevent the downtime. So here is the example of a servo gun friction. So based on FANUC motors, you can create, for example, a servo gun which looks like this. And this is an example from our customer when he got a notification from ZDT system, and they could check that there was not enough grease in the joint of this mechanism, and then prevent the downtime. And you can see on the screen that the situation came back to normal. So this kind of examples we are collecting. One of the examples is this one, when the customer got the information about abnormalities detected in the J2. It's a second joint of a FANUC robot, and then he checked the grease, and there was iron content in the grease detected. Customer make the action. So again, I will repeat what I said, that just the software, an indication from the software doesn't help the customer, but if the customer takes the action, then it's valuable. So thank you very much. Do you have any questions?
Thank you.
Thank you.
Okay, Conrad, you're going to sit down as well, aren't you? Because you're going to continue with the panel discussion. But please welcome to the stage Julian Smith from Polestar and Andy Jewell from In Touch.
Am I in the middle again?
Yes.
Hello again.
So you're going to be discussing incorporating digitization and IoT into your company plans. This is a chance for you all to get involved and ask questions as well. So I know we might have a different audience, so if you could just introduce yourselves and just say where you're from and why you're kind of being part of the discussion, that'd be great. Thank you.
Is it my turn? I'm Andy Jewell, In Touch Monitoring, being in the business of promoting and selling real-time MES solutions over the best part of about 33 years.
I'm Julian Smith, Managing Director of Polestar, that's Polestar Interactive. We're a network integrator working with these guys and also some of these guys as well. And I'll be doing a presentation after this if you've got any further questions about that.
Conrad Gross, I already introduced myself.
So let's just begin in terms of incorporating digitization. Where are we now? And then what are our plans going forward? Quite an open question there, Andy.
Where are we now? Probably not as far forward as we should be. I think is probably the sort of the easy answer. We could be a lot further forward, I think, in terms of the various industries that could adopt Industry 4, real-time FS, sort of shop floor data capture, MES, various acronyms for it, but it all means the same thing. Again, I've been probably trying to promote the ideology and the theory for the last 3 decades, and the story is very similar. And the adoption rate in certain parts of the world has been pretty good. In other parts of the world, it's been a little more fraught. But I think now with the advent of cloud-based technology, the cost of implementation is coming down. The ease of use, the fact that there's more younger people coming into the industries and working with the manufacturing environments, I think that's promoting the idea of the technology. So generally, I think we're moving forward, but probably not at the pace that I think is good in relation to possibly other parts of the globe. I don't know what your thoughts are, gentlemen, but I think that's a good starting point for us.
I think you can probably give us the view from Germany. But I think we know where we want to go. It's really about the best way to get there. I think that's what's giving people the issues and the challenges at the moment. And I think it's not been helped by the last 18 months of COVID, etc. But I think that's actually meant that we've had to become a lot more iterative. We've had to go back to the drawing board with certain things. And I think people are ready to try new technologies, try new ways of doing things, particularly when it's been to keeping the lights on. We've had some customers do really, really well from COVID, and some not so well. But it's really been, the ones that have been doing really well are afraid to make any changes, so they've been to change control, so nothing can be changed on the lines. And the ones that haven't been so busy have had some of the time to sort of take a step back and think, well, how could we use some of this time to do things better? So we're seeing people moving at different speeds now, whereas I think before pre-COVID, we were all sorts sat there scratching our heads going, how do we do this? How do we use this stuff? So that's my feeling of where we're at now.
Yeah, if I may add from myself, yeah, I remember 20 years ago I had appointment with a customer, and when I arrived to the gate of the factory, the customer secretary said that the meeting is cancelled, and I said, I called the person and I said, what's the reason? Because I have a downtime. But I said, but I just came to sell you the software to prevent the downtime. No, I have no time because I have a downtime. So it was awareness at the time was not yet there. So if I may answer the question, what has changed? So awareness is now on a much better level after 20 years. People know that they need to do something, but what to do and what is possible, it's yet to be discovered. I think we are learning, all of us. That's why FANUC is very open to partner with different companies and learn together, and how to bring the biggest value to the customers. So there's a big change of awareness, but I think now it's time to take the action. And it's not different in UK than other countries.
No,
I must admit that there's everywhere this same situation. Everybody's in learning phase. There is a lot of lessons learned. There is a lot of failed implementation of IoT on the market. There is some success story, and then I think everybody is learning what to do. And it's very exciting, actually, from engineering point of view and the management point of view. It's a very exciting journey, which we are now.
Interesting, a lot of it historically has been driven by OEMs forcing their customers to improve their methodology and ways of working. So I remember back to, and some may remember, this Ford Q1 specification for the automotive industry, and all of a sudden people suddenly started to wake up to the fact they had to do SQC, and then they had to do process monitoring, relate the process to the quality, which is what your previous discussion was about, more related to obviously machining rather than molding, but similar concept. Nip it in the bud, use process monitoring to control quality. So if all your inputs are consistent, then your output should be consistent. And that same thinking still is there today. But some companies, not many I might add, were doing it 20 years ago, partly because they were forced to do it and to retain their contracts with their OEMs. They decided to go along with it sensibly. But I think that's changing now, where people or companies are now wanting to do that, because obviously they do need to improve efficiency, they need to sort of provide cost downs, they want to get more production out for same people, same machine time, that kind of thing. But it's been an interesting sort of few years where it ebbs and flows, similar with energy monitoring we discussed earlier. I think somebody mentioned energy as being what are we doing about that? Typically the excitement turns up when the energy prices go up, surprisingly, and everybody wants an energy monitoring system. And then when the energy price was down at $50 or $40 or $30 a barrel, energy monitoring seems to be a very insignificant part of people's requirements. So again, it's about, I think, what's important, what's the drivers at the time. But I think now technology is embedded in now in the sort of front office systems. Slowly now we need to drive it more and more into the infrastructure of the manufacturing floor, get more machine data to the people that need to see it in a format that we discussed earlier, that's easy to use, easy to interpret, and get more and more usage and use technology to drive the businesses forward. But I think currently it's probably happening a lot quicker now.
Just going back to that energy discussion again, and I think I'm hearing in the news over the last week or so that compliance is creeping in with energy usage now. So the requirements do shift over time, but this seems like a constant, doesn't it, that isn't going to go anywhere, because we're going to have to start proving we are going to be more energy efficient from obviously the big players in the market, but then everybody else in the supply chain is going to have to follow in line and prove that they're doing their bit. I think the interesting, I was listening to the radio this morning, and I think the term is green cleaning, where companies pretend to be greener than they actually are. something like that. Maybe somebody can correct me. So, but the technology now, of course, is going to be able to make sure you can prove your green credentials and your energy usage, which you couldn't do before. So, that may be a competitive element in tendering. It may be a competitive element in talking to customers as well. I mean, I don't know where that's going to go, but I suspect that's probably going to be one of the things that steer us in that direction.
The real-life example is in the caps and closures business, again, plastics, recycling, circular economy, all these, again, words keep coming in, all relates to cost downs and reutilising CO2 reduction, that kind of thing. I believe, and there might be some people that could correct me if I'm wrong, but apparently 30% of the product has to now be recycled, reprocessed material. So now how do we measure that easily and quickly on a fast-moving production line? So again, technology needs to be implemented, data collection needs to be implemented. So interestingly, the automation of gravimetric feed systems that are OPC-UA compatible, that kind of thing now comes into the realm of data collection and being able to prove that to the HMRC or whoever it is that needs to see this data that they're actually putting 30% recyclate back into their products. That's typically, I think, the packaging industry, not the caps and closures, actually bottles. People like Coca-Cola will be forced to do that more and more, I think, in the future.
Do we have any questions at all? I've got one. I'm full of them. So barriers to entry, what are they? Because, we talk about cost, and I'm not just talking on a monetary value, but I'm talking about what's holding people back. Is it time? Is it training? And what do we need to do to kind of break that and open this up more and get this out to more companies?
Interestingly, cost has been a particular barrier historically with on-site service systems, on-premise systems. That's actually changing significantly now with cloud systems where rather than capital expense or capital investment, it becomes an expensible item. The software and the hardware itself has become much cheaper over the course of the last years. So cost has been an issue historically. I think that's been pushed to the side now. What I'm tending to find is the expertise within the organizations, again, in terms of being able to understand and adopt and implement and make use. The technology's there. Possibly supplier relationships could be better in terms of expertise, in terms of the delivery. But it seems to be the expertise levels, getting the right level to implement and make it a good implementation, a good project, rather than something that has been well driven, I think. A champion of the technology to drive it through the business.
How does that get solved?
Investment, training, people training. I don't know. That's pretty much
information sharing mainly. The information is not easy available. We are living in a situation where we have so easy access to information, but still the information which convinced customer, it's not easy to transfer the knowledge about the possibilities, but also to assure customers that the solution they implement will be reliable, will be secure, will take care about their data. Customers have a lot of concerns, sometimes that are not even expressed. They feel that something is wrong, but they avoid to take decision. But to discover the reason of the concern is a challenge.
I think it's a confidence, isn't it, though? That the information that they're getting is right. And it's the right information at the right time. I think that the cultural mindset needs to be, people need to become more familiar, more used to it, used to that technology, so that they're confident what they're seeing is right. And
I think the fact that there's younger generation is coming into the industries now as well helps with that, because we don't want to work with old technology. They want to work with the latest, greatest modern technology. And we need to be able to, as an industry, provide that infrastructure, I think. And it'll get there. It's moving a lot quicker than it used to. And there's a lot more young engineers now actually participating and getting involved in projects and driving projects where historically you never used to see young engineers or graduate engineers driving that kind of the business. And probably in the last 2-3 years, bar the pandemic, I'm seeing a lot more of that. I don't know if that's something that you're familiar with.
I've seen certainly the levels of enthusiasm
Definitely
are there,
yes.
you know, and the willingness to try new things and change things, and you know, having a level of experimentation because it is new, and being given the chance to do that in a way that's not going to impact on critical production, but can probably provide some of those benefits to the business. Which is, you know, a lot of the things that you guys are doing as well, you know, making it very easy to, oversimplifying it, of course, but making it easy to get some really quick wins by implementing a few little devices, and off you go. You can really show that.
That's right,
But it's just like if you want to change your tool or try a new tool, you get to try it, don't you? So it's almost like trialing it out to see it work before you go, yes, I can take this on board, I can work
The subtle
with this.
difference is a tool probably costs about £50,000
There is
to
a
make,
difference.
okay? Whereas a bit of software possibly can be loaned or lent or you know, free trials, that kind of thing.
Yeah.
Julian, you will talk about this in your presentation.
Yeah, I mean, and actually, it's true, but it's a good thing to say. I mean, one of the things that you can do with software, of course, you can do demonstrations elsewhere. You don't have to be physically being there.
That's a major advantage,
And
yes.
that's been a big help over the last 18 months, 20 months. People are kind of almost used to saying, well, if you can't show me the machine or what it does, or a video on YouTube, just can you show me what the software interface likes and how would we navigate it? And you know, this comes down to some of the VR stuff these guys are doing. It's what I've seen over the last couple of days has been, you know, really, really useful for bringing that to people. And you can do that with the software, can't you? Which you can't really do with the machine.
Yeah, this is important, is the complete experience, because experience of using IoT is not only gathering data, getting information, but also taking action. So this is what I discovered in my talking to customers and also having participation in real projects. Just seeing that software is working doesn't bring me any confidence, but experiencing by trying on myself that I can get the data, get information, convert data into information, and take the action. This is the total experience which customers can do based on the concept what Julian will explain in the presentation.
Yeah,
so it's a good introduction to your presentation.
And start simple, get success. And if it's a failure, it's not an expensive failure. You know, try things, be innovative, push the boundaries. But with certain projects, you can do that, and the cost is not great, so you don't mind doing it. It's slightly different when there's maybe a ton of metal there, and you made something, and it's probably not quite what you expected it to be, and it's a different story then.
You can't explain that through software,
No,
really.
You can't. No, that's it.
It's a book. It's a feature.
But
I think it's an interesting thing, isn't it? Failure is something we've been talking about quite a lot, and that fear of failure sometimes stops people, you know, trying new things. So I do wonder if IoT allows people to experiment more, because you've got the data assets rather than the physical assets, so you can afford to be a bit more playful and a bit more what if.
Yeah, in case of preventive maintenance or predictive analytics for preventive maintenance, without IoT the asset will fail anyway. So if you make a wrong prediction and the asset will fail, you have nothing to lose. So it's a very good method. Try and fail fast, and learn and improve. This is probably the best what we can do.
Any questions? No? Okay. My question to you, just to finish off with, is did you sell that customer the software when they said they got their downtime?
Not this customer, no.
Okay.
I have to come back to the customer probably after 20 years.
In the future. Thank you very much. Thank you.
Thank you.
Thank you.
Julian, would you like to take the stage?
I'll just get my notes, if that's okay. Thanks.
Okay, so Julian is going to continue.
Right. So hello again, back again. So thank you for allowing me to the open house event today and giving me the opportunity to present, to be with you here, and of course all of those of you remotely as well. So we're fairly new here. So I'll give you a brief background on me and Polestar. So I started out my career as an IT engineer, installing security hardware and software into places like power stations, factories, and data centers inside decommissioned nuclear bunkers. So I became fascinated with PLCs and SCADA networks at that time, and how the machines all worked and connected together. Some of the challenges we faced were really difficult, and we were pushing the technology to the limit back in the day. So off the back of this, I started moving into consulting and designing high availability networks for factory production systems, and eventually became the managing director of Polestar. Today's core theme is of course about Industry 4.0 and IIoT. So I'd like to talk not just about Industry 4.0 and the industrial Internet of Things, and where we see the benefits of the technology, but also the processes and the people, and some of the benefits that we've learned along the way I can hopefully share with you. Being in the right place at the right time is critical to success. And after all, it was only 60 miles away from here in Cromford, the birthplace of the first industrial revolution that led to massive cultural, political, and sociological changes. I think we're now starting to see some of those forces providing opportunity for the acceleration of digital manufacturing at a global level. First of all, though, we don't make cars, so I think I've said that a few times today and a few times to people during over the week or so. So Polestar Interactive has been in business for 23 years. As an industrial network integrator, we work across the supply chain with our end customers, but also vendors such as FANUC, Siemens, as well as IT vendors like Cisco, HP, and Microsoft. And we work in partnership with specialist OT vendors like Dispel and Nozomi on industrial cybersecurity. Our core focus, though, is delivering projects through professional and managed services for clients looking to upgrade their site technology and digitize existing ones, or even build new sites. And most of our customers are based in EMEA, are in the manufacturing sectors, from startups to established brand names, and from automotive to fast-moving consumer goods. I thought it might be useful to talk through a couple of projects we've been involved with recently as an example of what we do. Barclay Modular is part of one of the UK's largest FTSE 100 construction companies. The Barclay Modular spin-off, though, is dedicated to building modular housing components. So rather than using third parties, which they've been doing for several years, they decided to build their own factory. And this was to improve quality and speed up the overall supply for the delivery of the buildings. Barclay built a brand new greenfield site with quality and efficiency being the main drivers behind the requirements. And to achieve this, they knew they needed to have lots of data insights into production performance, supported by highly available, resilient, and industrially secure networks. So we were brought into the project to as specialists for the critical networking design and the deployment of it, all the way from the overall network architecture to the delivery of the factory network. And they're starting small now, but they're scaling up and building 2 new factories in the next 3 years now. They've only got 3 robots at the moment. On the other end of the scale, we also work with Reckitt, one of the leading brands of fast-moving consumer goods. They've got lots of robots. They also produce COVID-killing products like Dettol, which is as well as Nurofen and things like Strepsils. And they undertook a significant program to understand and standardize their factory environments to improve quality and to reduce cost and risk by delivering visibility of what was going on in their existing factories using IoT. These programs will continue to deliver benefit for many years to come for these companies, but not all of the benefits are going to be realized immediately. Both companies were able to benefit, though, from increased uptime and less unplanned downtime in the following months. What can digital transformation do for me and my business is a question I get asked all the time. I'll let Deloitte answer this. They said in 2020, the 4th industrial revolution, 72% of CXOs view IIoT as a set of technologies that will have the most profound effect on organizations. And 18 months ago, I would have given you a different perspective on Industry 4.0 and IoT that I would do now, and how we in our businesses should think about adopting some of this technology. But the last 18 months has changed my thinking about this a lot, and a lot of the people I talk to as well. And they're saying the promise of IoT technology looks great, but right now I don't have time to invest money and time to play around with this stuff. What does it do? What is it actually going to do for me and my business? And they're all good questions. So hopefully it's going to do one of the following. Value chain digitalization, digital transformation, smart factories, industry 4.0. These are all labels, of course, and they're really describing movements at the end of the day, or evolutions rather than revolutions. So we've come for industry 1.0, steam, water production methods. Industry 2, electrification and communication. Industry 3, which quite a few people are still at, digital computing and engineering silicon. And all of these are physical and still in use. The difference with Industry 4, though, is that it's not a physical thing. It's a combination of all of these previous evolutions. The output, though, is not a physical product this time, or an improved process. It's either a 1 or a 0. In other words, it's the data. And data is accumulated and or then recombined in order to improve upon the end product, or it's sold on as an asset in its own right into the supply chain to help others. Industrial internet, in order to use or produce the data, your systems need to be connected. And not just to each other, but also to other people's networks and other people's systems through things like cloud services. And that prevents many challenges and obvious security implications, but the one constant is that it's inevitable. And it's better perhaps to grapple with the connectivity conundrum now and learn how to solve the challenges rather than having it imposed upon you. Thankfully, edge technology allows you to move at your own pace with this. And simulated environments is the value realized through the collaboration, through the use of the data and the connectivity. In the end, this may give you an advantage over your competitors, but only if you do it at scale. And you need to do it at scale in order to be effective. So proof of concept and proof of value projects can be really useful for deciding on technology adoption, but the key question is, which do I choose? And can I scale it up at speed when I need to do so? I do have to mention the numbers, of course. So Credit Suisse's February 2021 report quotes Kembashi as estimating the IoT market to be worth 11 billion in 2020 and forecasts it to grow at 20% CAGR between 2020 and 2024. And the largest market, though, for that is 3 billion. It comes from manufacturing. And production with assets just under 2 billion, so that's nearly half of that value. And we've seen at first hand IoT technology gain traction with end customers specifically in the last 18 months. And quoting Credit Suisse again, in their July 21 report, they say that CIOs have realized the importance of developing a company-wide digitalization strategy, and 60% of those they interviewed reportedly have a strategy. And through these improvements, they may expect those benefits to be realized. Or I think putting it in simple terms, achieving high levels of predictability. Being able to predict means that you have the ability to create metrics which enable you to optimize, streamline, and then calibrate your processes. And you all know better than I do that the manufacturing industry is intrinsically built up of a combination of technology, machinery, people, and materials. And all of these are variable. So effectively running a manufacturing company means coping with change. Therefore, being predictive and getting ahead of change is crucial, as is the preparation to manage the risks, challenges, and seize those opportunities. I do have to mention the threats, and the elephant in the room with IoT really is cybersecurity. And using IoT technology to connect stuff together will expose known and unknown problems very quickly. And we've seen massive damage caused by threats like ransomware, leading to downtime and loss of reputation through data exfiltration in the last 18 months. But from talking with customers and our partners, the feeling right now is that the investment in new tech is the least of their worries. There's too much going on and they can't produce as everything's coming at them at once. Higher energy bills, as we've mentioned, cost of raw materials, not getting enough labor. There isn't enough capital available to do the future stuff. And squeezing your supplies isn't an option anymore, as they're already squeezed before COVID and Brexit, at least in the UK. Quality and cost management will always be the main goal, and the number one argument against spending on cybersecurity technology is, I don't think I need it, it hasn't happened to me yet, and where is the ROI in cyber? But visibility is a positive outcome. of investing in plant security and understanding what the lines are doing. It doesn't just give you peace of mind, it also enables you to be more responsive, productive, and sustainable. So if cybersecurity is baked in at the beginning, then those benefits can be realized without pain, and instead of cybersecurity, we call it loss protection. Before we can implement the right IoT technology, we need to look at the wider picture. The impact of COVID is not only making people work differently, the current landscape is really about push and pull factors. The pull factors are remote working, collaboration, reshoring through and negating the need for distribution, budgets moving from IT to OT and from CapEx to OpEx models to get things moving again. The push factors are things like decarbonisation programs, isolating staff from COVID-19 on the lines, not enough lorry drivers for supply chains, and lack of skills to deal with these push factors. And from a technology perspective, the three main challenges to most businesses that we're all familiar with are the legacy networks, don't have the right protocols or obscure protocols, closed systems, because the intention was not originally to share data between machines, insecure architectures where it's not possible to share data for operational reasons. And information technology has provided some help in overcoming these challenges for manufacturers, but particularly with collaboration in the last 18 months. And there are steps that can be taken to use IT methodologies to provide other benefits too. Where automation meets IT is called OT, or operation technology. If you're not aware of that, because I've mentioned that a few times and a few people have asked me what it means. It's tricky to know where to start though. Stage 4 is where most people start and where they find themselves when we talk to them. Businesses need to understand what assets are out there and how they might connect to each other. Many already have this information, but it can be in plans, spreadsheets, and other people's minds. And there are tools, some very good ones that are available now that will help you map out what you've got to a high degree of detail. It can also help you with that loss prevention headache. But these tools will only give you an operational view of a particular machine, line, or a plant at a point in time. It's not going to get you closer to leveraging other benefits of digital transformation, like connecting with your customers, your suppliers, and realizing new business models or opportunities. So we would urge you to start with the end in mind with your own business, which is step 1, and ensure that consensus across all the stakeholders, whether it's automation, engineering, IT, maintenance, security, is in place. Everyone should be pivoting towards the same objective, creating standard operating procedures, operational technology reference designs, and policies across the whole group. And these activities need buy-in at all levels, and by doing so, you can get to step 3, and you should be in the right place to define the logical ownership of those various assets and the layers of the systems. And this will allow you to plan and then appoint new responsible owners where there are currently gaps or duplication of roles. By creating your standards and policies, you can build in virtual teams and stakeholder oversight, and you can discover your assets, calculate the ROI, and hopefully successfully argue the case for those budgets. And one thing we've learned from our customers who have done this is that it needs to be an iterative process. Don't be tempted to create a guidebook that people should follow exactly to the letter. Step 6 is more about understanding the headlines and people signing up to follow them. And by being too prescriptive, what we found is people will just ignore the plan and go ahead and do their own thing. So instead, build in ability for exceptions and accept that some sites or facilities are going to get there faster than others. There are common challenges across the organisations we work with, and we hear the same problems just about all of them. From the large enterprise teams who say we don't have the leadership skills, budget, IT and OT, automation departments who just don't get what we do. And the smaller organisations might not have the financial resources, but they do have an advantage over the big organisations. They can be much more flexible and can move at speed. The challenge for the SMEs, though, is the direction of travel. And there's a need to put it all together, as all organisations will derive the same benefits from IoT technology and Industry 4.0. But all organisations lack the capability to deliver strategic intent at some point. So from the top down, directors and managers know what needs to be done. For example, some of the strategies often used and heard about are cloud first, data-driven, cyber, etc. And then from the ground up, the engineers and the operators need to be able to construct the building blocks in order to create the foundations to deliver that strategy. So we call these the 3 C's: connectivity first, collaboration second, control third. And we do the bits on the left. When we started getting our heads around what Industry 4 and IoT was, there wasn't a roadmap, so we set out to build our own policy templates that could be used to help companies plug the gaps in their silos and deliver that strategic intent. So the outcomes from this were leadership and governance, working with the business. We identify who the key stakeholders are, and these are the people who understand what needs to be done but don't know how to get there. And the owners of these assets can be anybody in the business. It can be the directors, it can be managers, it can be engineers, it can be operators. The knowledge is there. Skills at departmental level to get real organizational change, OT, automation, IT, all need to work together. So setting up virtual teams comprising not only of stakeholders but also peers in other companies or industries that have already been there and learnt some of the lessons is really useful, because some of those skills like data analytics and cybersecurity are really, really hard to get hold of the right people. They're really very much in demand right now. So if you can reduce the amount of time to mature in those areas by using trusted technologies, it can bring the same competitive advantage to companies large or small. With data, most organizations already have an exceptional knowledge of their systems and what may need to be done to optimize a process or speed up or slow down a line. The problem is that knowledge usually isn't transferable across the business from one site to another, let alone through the business itself. You may already have the data aggregated in SCADA, MES, ERP systems, or you may be starting from scratch with data coming directly off a PLC or a sensor on a machine. The objective has to be, what does good look like, and how can we centralize that at an organizational level to benefit from those digital twins, and how can we remotely access those machines to make sure they can carry on doing what they need to be doing at scale. With the technology, use the right technology and the right vendor to be more productive sounds really simple. And we often hear, if I had £1,500, I can buy a new PLC for that. That would make me more money and save me more downtime than this IoT box you're trying to sell me will ever do. The irony is, of course, that they're the same thing. But to be fair, 80% of the IoT tech on the market is more or less does the same thing that all the other ones do. But it's the 20% with the well thought out and well managed technology that delivers the real value and return on investment. So how do you acquire data in an age of zero trust? This is where a practical ground-up, secure by design approach is needed. 90% of our customers are running factories with technology that is up to and sometimes over 30 years old, and some of that's even older. A lot of the conversations revolve around how to expose data points from their control systems to the enterprise to drive those efficiencies. A common problem is that IT departments don't have the time, resources, or knowledge to protect the actual systems that make the business the money. Collaboration, Office 365, standardization around cloud-first projects for corporate applications, and cybersecurity in the enterprise all contribute to the problem for IT teams to stay current and up to date. So they're busy off doing other things, way too busy. There are, fortunately, those standards like IEC 62443, which are effective when protecting industrial control systems. But for manufacturers, they can be too costly because generally they have a large number of assets in a very small area, and they have a large number of assets in quite a large area if you take that globally. So it's very, very hard to implement. So getting visibility on those assets is a major problem. And even if you have the knowledge within the business to make the right decisions, which devices can communicate with each other, the approach that is taken is usually to ring fence the assets by installing multiple firewalls at zone and cell levels. This doesn't solve the problem, as we know that most attacks come through enterprise services and not, as you would probably expect, through industrial control systems. We do see this a lot. And this is due to the high demand and the high number of services that require to be open in an enterprise in order for information workers to do what they need to do. So what we're seeing, particularly with the COVID-19 production, is a lot of customers running 24/7 production schedules with the emphasis firmly on keeping the lights on. And that doesn't give much headroom to implement new technologies, such as secure remote access for support, maintenance, and commissioning quickly. So what can be done to minimize risk without having to rebuild a production network from scratch? We've seen through COVID that a lot of customers running 24/7 production. Business need is driving faster adoption of cloud technologies, though, giving automation and OT the promise of being able to get on with what they do best and create products. Cloud also provides the opportunity to bring IT, OT, and automation teams together to collaborate more effectively. So we've seen lots and lots of people use Teams, WebEx, Zoom, all of those tools to get things done. Transitioning other applications to cloud platforms, though, can also provide transparency, and moreover, you only need to build and deploy them once, rather than multiple times across your facilities in the cloud. Moving beyond dashboards, a good example of a cloud technology that people within the business can relate to and see for themselves, thus creating an easy win, is remote access. Secure remote access to production systems can be used for commissioning, preemptive maintenance, and support. And the approach we've taken is to move the remote access risk to the cloud to centralize it where it can be carefully managed. Although these features are for remote access deployment, they are common requirements when transitioning on-premise infrastructure to cloud applications. So, for example, with the interface, you need or want to get to single instance management, a single pane of glass. All of the dependencies such as access requests, security settings, traffic logs, and screen recordings through one centralized console. From the connectivity part, you want all the users, no matter where they are globally, to have the same end user experience. Traditional secure remote access methods are built out of components from multiple vendors, creating friction, and it needs to be in seconds, not minutes. And then the analytics, integrating your industrial control system with providers that speak IT protocols like syslog, turns data into actionable tasks that you can give to security, IT, and DevOps teams. And finally, scalability. Standardized deployments minimize confusion by giving users, whether they're engineers or integrators, only the applications and capabilities needed for a particular task at a particular time and facility. So I mentioned earlier, am I confident that the data I'm seeing is telling me the right information? And what I really need to know to make those decisions. How do I deal with the variability of the materials and the environments? And how do I solve that through predictability? So starting with the end in mind, without necessarily knowing how you're going to get there, is where we're all at now, from SMEs to large enterprises. And reducing this down via an IoT approach, on the left-hand side, these are effectively the 8 areas or problem types that have been identified and which digital technologies can help with. On the right-hand side are the solutions and products and services, in a lot of cases, that can help you address those problems. What we've seen in the last few years is a proliferation of point solutions, though, that vendors are using to address some of these problems, and a lot of companies are well on the way to adopting some of these, or in the process of testing them. And it's not been uncommon with some of our customers to hear that they're testing 100 or so IoT products or projects at any one time, which is crazy. The proliferation problem, though, is a real one. And as devices get smarter and connect to more networks, it becomes harder to manage them. And the responsibility for managing them is difficult to ascertain. And it already is with a lot of existing industrial control systems, as you know. So if you're looking to build that digital twin, and you have multiple vendors with compute capability in their hardware, which can be anything from a Raspberry Pi to a soft PLC, then where does the responsibility lie for the data capture? And a little anecdote here. A few years ago, I was talking to the inventor of the Hive about IoT and his smart thermostat system that he managed from your Siri or smartphone. And he discovered that there's 25,000 devices. There's an inflection point where it becomes impossible to manage them centrally without orchestration tools and potentially AI capability. So depending on the number of assets you already own across your factories and facilities, it may not be long before you reach that limit. So how do you start to scale, safe in the knowledge that you will be able to maintain control at all times? So the answer to this is at the edge, and this is where the data can be maintained and managed, and if that capability is what I saw in the FANUC field platform. So to us, the field is effectively a concentrator, a device which aggregates and forwards data packets within a system, and it's an open platform as well. In the 1990s, when I started my career, there were 20 different Unix versions. Now there are only 3 or 4. So some of those that have fallen that were very prominent were based on proprietary hardware. Nowadays, everybody's developing for open versions of Linux, and which of course is what Field runs on. So I think with FANUC taking some of that management of the hardware pain away and vendor application compatibility away, then that's going to really free it up for application developers. Some final comments as I'm running out of time. As we emerge into what's hopefully post-COVID world, what lessons have we learned and how do we build on some of the successes? Overall, people I think are sold on Industry 4.0 and IoT. They're creating digital twins, joining solutions together through connectivity, driving the business in the right direction. The lessons we've learned is that you can do things better, and capturing the skills used throughout the business and digitizing that domain knowledge or expertise will give you that competitive advantage. But keep in mind that it needs to be safety first. Everything needs to be built in with safety in mind. It needs to be able to scale, so you can be using it in 10 to 20 years' time. And it needs to be future-proof. Focus on the end game. It's about analytics now, but in the future it's going to be about control, and whether that's from the cloud or on-premise or the factory floor. You need to benefit from those 5% iterative improvements now. You'll be more familiar with the technology as you grow. And thank you very much. That picture is taken on the way, on the M3, on the way to FANUC a couple of weeks ago when I was stuck in a traffic jam. So thank you very much for your time. If I have any more time left for questions, I'm happy to take them.
Thank you, Julian. Thank you very much.